If you have been existing on Earth, you must have heard of beverages like tea and coffee. And the process of making both of these is quite similar. First of all, you boil some water. Second, you pour it in a cup. We're making instant tea and coffee, by the way. Then you add your tea bag or instant coffee, and lastly, you add some condiments for taste. In this algorithm, the first and second steps are common, but the last two steps are different. So it seems like we can add some sort of template to this method. Am I right? The template method pattern defines the skeleton of an algorithm in a method, deferring some steps to subclasses. It lets subclasses redefine certain steps for an algorithm without changing the algorithm's structure. Let's take this idea to our tea and coffee. Our process used to look something like this. All of the steps are in separate methods in tea and coffee class. Now, if we templatize this process, it will look something like this. So we have an abstract base class at the top, which has a template method called prepare recipe. This method defines the algorithm as a set of steps. Next, we have the concrete methods, which are common to the algorithm. And primitive methods are those which need to be implemented by the subclasses. And lastly, there are some hooks which give subclasses an ability to do something different in the algorithm apart from what is defined in the template method. Let's code this up and see how it actually works. Alright, this is our code for the template method pattern. Let's look at this abstract class first. So this abstract class is called caffeine beverage because we are trying to make caffeine beverages, tea and coffee. These two are the concrete methods which are common to this algorithm. That is why they are implemented straight away in the abstract class. Next, we have the primitive methods which need to be implemented by the subclasses. That is why they are defined as abstract. Next, we have the template method, which is the method that defines the algorithm. So the algorithm is boil water, pour in cup, brew, and add condiments. And this is where the hook comes into the picture. A hook is simply a method that lets subclasses do some crazy stuff with the algorithm. So if you see here in the algorithm, there is a condition: if customer wants condiments, then we add condiments. So this customer wants condiments is this function over here, which returns a value of true by default. But we can override this method to return false in one of our subclasses. Let's see how it actually works. So this is my tea class, which extends this caffeine beverage. So it has a private boolean data member, which is want condiments, through which I can control if I want condiments in my tea or not. So here, this value is taken up in this parameterized constructor. So I can pass my value in a constructor and it will take up that value. And this value is actually passed in the customer wants condiments, which I am overriding from that caffeine beverage class. So I'll return the value of this data member. This lets me have control over if I want condiments in my tea or not. Let's look at the coffee class also. So here I am just extending that abstract class and implementing the primitive methods, which are brew and add condiments. Let's try to run this code. So in my main function, I'm creating a special coffee, which is simply a coffee, a special tea with the default value of want condiments, which is true, and a special T2 where I am passing want condiments value as false. And then I am trying to prepare the recipe of each caffeine beverage. Let's see the output of this program. As you can see here, for coffee, it is boiling water, pouring in a cup, dripping coffee through filter, and then adding sugar and milk. So basically it is adding all the condiments. Then for special tea, not the T2, it is boiling water, pouring in cups, steeping the tea, and adding lemon and ginger. But for our second tea, it is boiling water, pouring in cup, and steeping the tea, and that's it. It is not adding the condiments because we passed the value of want condiments as false. So yeah, this was all about the template method pattern. Let's look at a quick summary. So a basic class diagram of this pattern looks something like this. There is an abstract class which has a template method which defines the algorithm as a set of steps. And those set of steps are either concrete operations or primitive operations. And lastly, there are some hooks which lets you do some crazy shit with the algorithm. And concrete class extend this abstract class and implement their primitive operations. So the template method pattern defines the skeleton of an algorithm in a method. The concrete operations are those which are common in the algorithm, and primitive operations are those which need to be modified by the subclasses. And lastly, the hooks are those methods which give the subclasses an ability to hook into the algorithm. That's all for this pattern. All the theory and code you'll find in the description. And thanks for watching.